The first question is about finding the max of two numbers. Let's say we call them X and Y. Okay. And without using any comparisons. Okay, direct comparisons. And no if then else kind of, obviously comparisons will lead to that, or branching. This is a constraint given. Okay, now so these are two numbers, so we made the assumption that they are signed integers. It's pretty jumpy. Okay, so when such questions are given, normally you think of, so with these constraints, no comparison, then the first thing that comes to your mind is, are we allowed to do arithmetic? Yes, you can do arithmetic operations or arithmetic expressions. You can do bit operations. Okay, these are two things that you are allowed to use. So you're supposed to find whichever is X greater than or equal to Y, or X is less than Y. This is basically the logic for finding a max, right? So the question is, how do I replace this with only arithmetic expressions and this bit level operations, right? So the key thing is these are the discriminators, right? Greater than, equal to, and less than. How do you do that? So you start with, so you're allowed to do X minus Y. Typically comparison is done by finding the difference. The question is, if X is greater than or equal to Y, then the sign bit will be 0 in this case. And if X is less than Y, sign bit will be
1.
So this problem becomes now how to check the sign bit, and without doing an if then else or such comparisons, right? So let's see how we can do ahead. Yeah, so the problem becomes, how do I basically find the sign bit, right? So here is one way you can do. So you have X minus Y as a number with the sign bit set. Now, if you do a right shift, let's say 31 bits, okay, you know that in ARM, there is something called sign extension, which means if the sign bit was set, all the bits will become 1. So this is a sign bit. So this was initially whatever number, don't care. Okay, when you do a right shift of 31, so sign bit and all the other bits become 1. And if the sign bit was 0, it becomes 0. So essentially, you are from the sign bit, by doing the shift, you are getting an FF kind of thing, or so this is the value you would get. Now, next step would be, how do I check whether it is FFFF or 0000? So you do an AND with whatever you got, that is the shifted X minus Y, right, shifted by 31. So you get a mask of FFFF, then the AND operator will return same X minus Y. Otherwise, it will return 0. So you got, when this expression is evaluated, you either get an X minus Y or a 0. What do you do next? Then you need to give a result, right? So what you do is X minus whatever that expression is, X minus Y and X minus Y, right, shifted 31. So what happens? You either got, if X was greater than or equal to Y, then you would get a 0. So X minus 0 would become X. So you got, since X is greater than or equal to Y, you got the answer X, which is the max of the two numbers. If X was less than Y, this was FFFF. When you do AND, you get X minus Y. So X minus Y will give you Y. So the solution is basically, the complete expression would be X minus Y and x minus y right shifted 31 bits. This is the way, this is one answer basically. So the idea is that you don't do the comparison, use the sign bit, and you could actually do this expression where there is no comparison. The key thing here is that sign extension. So the key trick there is that this will work only on those architectures which do sign extensions when you do the right shift. And the ANSI C by itself may not, may leave it to the implementation of the compiler on.
So it is the arithmetic right shift.
Yeah. Yeah. Okay. So is it clear?
Yeah.
Now let's
Yeah. It's
see
clear.
another solution we can try. It is also a simple thing. So again, basically, think of this x minus y, and you think of the absolute value of x minus y. Okay. Now, if x is greater than or equal to y, the absolute value of x minus y would be x minus y because it is positive. And if x is less than y, which is a negative number, then what is this value? It will be y minus x, right? So what you do is you just have to, so you got x plus y plus absolute value of x minus y. If you take this, so this is a fixed part. So if x is greater than or equal to y, you will get x minus y. So x plus y plus x minus y will give you 2x. And if it is y minus x, you will get 2y. So the answer would be, you just have to divide it by 2. So x plus y plus absolute value of x minus y divided by 2. This will either give you x or y, which is depending on the condition, whether x is greater than y or less than y. So this is another solution. Of course, you need to be sure that the function that you use for absolute computation doesn't violate the problem statement conditions. Many times in the interview situations, they may dig deeper to know whether you just use a library function without knowing its implementation. Now you can, there are versions, I'm not sure all implementations of absolute use comparisons or not, but you could write your own absolute function, which basically does something similar to what we did in the solution one, in order to determine whether it is positive or negative value, the x minus y or y minus x, which it returns. But yeah, this is basically working at the algebraic level and not worrying about the implementation level details. But in a real world situation, this is perfectly fine. Of course, this is a contrived interview question, so they may dig deeper into, do you know how absolute function is implemented, or can you write your own absolute function? Okay, so the problem may get into that track.
So absolute function, does it needs comparison?
You can do any way. I mean, if you, there could be, I'm not sure. If you compile or you disassemble and see, you may say whether it, more efficient ones may do all that. Only in an interview you will do all the unnecessary arithmetic, right? But you can say, I can write an absolute function without doing the comparison. But this is okay. This is one alternative solution, right? But be prepared that the interviewer may ask about the absolute functions violating the constraints. Now we could also use another trick. So let's say you take this fraction x by y. Okay, if x is greater than or equal to y, this x by y will be greater than or equal to 1. Okay, it may have a fraction part, you forget that. And if x is less than y, you will get 0. I mean, at least the integer part of it, right? So here is a trick. Again, it's specific to the language and the compiler. But so you want to be sure that you are getting either a 1 or a 0, not a 2. For example, if x is a multiple of y, then you will get a 2 or a 3 or whatever it is. So you want to reduce the x by y to a number 1, and if x is greater than y. How do you do that? So if you see in C++ at least, there is this bool type. So the bool type, the true and false representations are exact there. So you get a 1 or a 0. It's not like 0 and not 0 kind of value. In C, it is, 1 is false is 0 and true is not 0 and so on. But in C++, when you cast a value to an integer value to a bool, it will give you either a 0 or 1. So you could use that. So when you say bool of x by y, it will, depending on x is greater than or equal to y, it will give you a 1 or a 0. Okay. Now you can use that to do our problem. So you take x multiplied by pen started. Okay, so x multiplied by bool cast x by y plus y multiplied by bool casted y by x. If you take that, okay, what would you get? Depending on if x is greater than or equal to 0, you will get x times 1, which is x, and y times 0. So you will get x. Yeah, when this addition will give you x. If x is less than y, then you will get 0 on the first term and y on the second term. So yeah, this is another. Okay. Now all these are independent of embedded system concepts. What you need to know is number representations and type conversions for a particular architecture, and of course, like arithmetic shift, right, sign extensions, those kind of architecture dependent concepts is basically what you are bringing to this solution. Now, if you want to do a direct solution, you can write in assembly language, in ARM assembly. In ARM assembly, basically here we may be actually cheating. For example, you do a sub. Okay, with the suffix sub s. Oh God, I'm having a lot of trouble with the pen. Okay, sub s. When you do sub s, let's say R0, R1. Pen is very jumpy. So let's say our numbers x and y. So there is one is in R0. Okay, one is, not sure why it's not writing. Sorry about that. So let's say our x is in one register R0, y is in R1, and result can be, sorry, let's say x is in R1, y is in R2, and result is going to be in R3, and we can use R0 as a temporary register. So, oh my God, my pen is really.
Yeah, it's not working.
Let's see if it's a problem. Powering off, although it's charged. I'm having a bad day today. Sorry about that. I don't know why it's cranky. Anyway, so the point is, I will just to save time, I will talk. So you can do a subtract operation, and then there is something called conditional execution. In conditional execution, you are not doing the comparison, it is a hardware which is doing. So let's say when you do the subtract of x and y, and if x is less than y, the sign bit will be set. So you can have a move instruction, which is basically, you can say move positive or zero, move PL. Okay, how am I going to do this? This is freezing on me. Okay, so move instruction you could do with the conditional suffix move PL, which means positive or zero, then you return R1, and move MI, which is when it is negative, you are actually returning 2. Now you're actually not doing it in your code, the comparison and direct comparison, but you are doing a subtraction using the condition flags and letting the processors hardware to do the thing when you're basically you're actually using the conditional expressions. This is a bit of cheating, but you can say your assembly language.
Okay.
So that's just an escape. Okay, so we talked about multiple solutions using pure expressions with right shifting, arithmetic right shifting with sign bit extension. And then we did basically a bool casting of a fraction to make sure it is 0 or 1, or you could use an absolute value. So these are some things that I could think of.
Yeah, it's really helpful. Yeah.
Now, how am I going to proceed with this pen?
Yeah, the second question that I asked, I know the solution. Actually, I found a good video from Omkar about bit manipulation. So in that, he explained that question, the second one.
Great. Then I will move on to other questions.
Yeah.
Now, how am I going to do that? Pen is really, I don't know, it doesn't allow my hand to be used as pencil also. Just okay, I will talk and I'll try something. So Tejaswini is asking, I worked on driver firmware and not really used embedded Linux. So how do I approach this knowledge gap? So Tejaswini, it's very simple. If you work with drivers, okay, basically, so when you talk about drivers, there are two parts to that. One is basically the peripheral device that you're driving. It has its own functionality. It has its own register interfaces, maybe memory mapped. It has its own protocol. It could be a serial protocol. It could be a USB or whatever. Basically, those are the things very common, whichever operating system you use. It doesn't matter. It is common, and that part will come handy to you. There is no doubt about it.